Hello everyone, I'm Mohsen Somboleslam from University of Southern California, and today I'm going to present our recent work on hierarchical adaptive control for collaborative manipulation of a rigid object by quadrupedal robots. Legged robots have shown an impressive result in navigating challenging terrain. They find practical application in industries like logistics, last mile delivery, and construction, where the task often involves handling packages. In our previous research, we introduced an adaptive local manipulation control system that leverages the robot's body to manipulate objects while maintaining stability and adapting to unknown parameters. However, for tasks involving the large and heavy objects, a single robot is insufficient. There should be multiple robots collaborating with each other to accomplish the task effectively. In the team also, the robots must exchange certain information about the object, such as its mass, inertia, and center of mass location, which are most of the time unknown in practical situations. Moreover, in order to have a versatile approach, the proposed method should be generalizable to any number of robots in the team. Therefore, we propose a control framework with 3 levels. First, we have an adaptive controller for object manipulation. The controller can adapt to both the object and terrain uncertainty, and therefore it computes the manipulation force and moment for the object to follow the desired trajectory. Then, using a QP-based controller, we distribute the manipulation force optimally to a team of robots. The QP-based controller computes the optimal value of the force and contact point location for each agent in order to achieve the overall force and moment computed based on the adaptive controller. Another important property of the QP-based controller is that it is independent of the number of agents in the team, and it is flexible to adapt to any number of agents. Also, it can maintain the contact point location within the range of the object surfaces, which is very important in object manipulation. Then we use a decentralized local manipulation control for each robot that considers locomotion and manipulation at the same time. We have a unified MPC that integrates the manipulation force and contact point location that achieved from the previous QP-based controller into the conventional MPC for locomotion. So the unified MPC regulates the manipulation force in order to not sacrifice the robot's stability. Now let's go through the simulation results. In the following simulation, we will demonstrate the effectiveness of our proposed approach by comparing it with some conventional methods. First, we compare the results of the adaptive and non-adaptive controllers. From the plot, it can be obtained that the tracking improved significantly when we use the adaptive controller. Next, we show the effect of the QP-based force distributor with respect to a simple heuristic policy. As observed, the QP-based controller can distribute the manipulation force optimally while satisfying the constraint for each agent, such as keeping them within the limit of the object surfaces. In the next simulation, the team of robots start manipulating an unknown 5 kg object on different terrain with unknown friction property. As you see, they start from the hardwood ground, then they cross over the grass field, while they can adapt to different terrain with different unknown friction coefficient. In the last simulation, the manipulation of an unknown heavy object starts with 2 robots, and then the third robot joins the team to improve the performance and help the other robots. Remember that the combination of adaptive controller and QP-based controller give us the flexibility to handle unknown objects as well as adapting to any number of agents. So we can add or drop a new agent during the manipulation task without affecting the overall performance, which is one of the most important advantages of our method. Thank you for your attention. If you have any question, I'll be happy to discuss them during our poster session on Monday, October 2nd in IROS.